Okay, now let's have a look some examples. Okay, now we have a girl with a mass of m travel on a track through a deep. Okay, the lowest point with a r speed is this. What's the upward force of the track on the girls? So this time they're asking for the normal force. Okay, so if I draw a diagram, now I have this girl here. Now we need to step one. We need to label all the forces. Okay. Now I have a gravitational force, mj. Okay. I have a normal force go up. Okay. Also, I have a centripetal force. Okay. Just let me label it like this. FCP towards the center of the circle. Okay. Then we need to find the normal force. Okay. So let's write down an equation. Okay. My sum of all the forces, which is my net force, which is my centripetal force, is positive because it's acting upwards, equals to the sum of all forces, normal force take away the weight force. Okay. Write this down, you have 1 mark. Then my centripetal force is mv squared divided by r equals to normal force take away mj. Okay, rearrange the equation. New normal force will be mv squared. Oh, sorry. Sorry, that's right. Divided by the radius plus mj. Rearrange the equation. My normal force, put down the value. 50 times 6 squared divided by 4 plus 50 times 10. Okay. Now, if you do the math, okay, 36, 450 plus 500, the normal force will be 950 newtons. Okay, down. So again, okay, the important part. Okay, you need to be able to derive this equation. Okay, once you derive this equation, you get 1 mark. Okay, you get another mark for the final answer. Okay, also drawing a diagram. Okay, if you be normal, you get 1 mark for drawing the correct diagram. Okay. Now, sorry. Let's go to the next question. Okay. Now this is a roller coaster. Okay. So we have a radius of r. Okay, and I have a mass. Okay. So yep. Okay. What's the minimum speed? Okay. Now again, similar. It's a similar thing, but different scenario. The idea is, if the trolley move on the track, if it's too slow, okay, it will fall when it's on top of the track. Okay, it will fall here. However, if the trolley moves fast enough, it will be able to travel through the track safely. So they ask me for the minimum speed. Okay, now for this question, let's do, so assume the track is here. Okay, let's draw the force diagram. Okay, remember the trolley travels inside the track. It travels inside the track. So the normal force will be in this direction. Okay, normal force is a force surface acting on the object. Okay, so now the surface is here. Okay, the object is downwards, so the normal force will be downwards. Okay. Then I have my other force. They're all downwards forces. Well, my weight force. So just let me extend it here. Okay. I have my weight force mj. Okay. Afterwards, at this point, I should have my centripetal force in the downwards direction to FCP. Okay, so yep. So let's write down an equation. Okay. They're all downwards. So okay. Remember, sum of all forces is your net force. In this case, is your FCP, okay, which is minus because it goes downwards. Okay. Now you have a minus normal force goes downwards, take away mj. Okay. If we rearrange it, okay, FCP take away the minus signs, it will be plus. Okay. Now your centripetal force is mv squared divided by r equals to your normal force plus mj. Okay. Now, in order for it to stay here, the minimum speed, okay, n should be 0. N must equal to 0 for minimum speed. Okay. If your normal force is less than 0, means it fly away. Okay. Means, sorry, in this case, means the trolley drops down. Okay. Then use your equations. So you have your normal force will be 0 equals to mj, cancels out, v equals to square root of rj, the same equation we have. Okay. Put down the value, radius will be 7, gravity will be 10. Okay. Use your calculator, find out the answer. Remember, your answer should be in 2 significant figures. Okay, down. So again, I have to mention, you get 1 mark writing down this. Okay. You get another mark giving out the right answer. Okay. Also, you will be given 1 mark, okay, for labeling the diagram. Okay. However, if you memorize the equation, you use this equation here previously, okay, well, then you're not going to get 1 mark here. Okay, you're going to lose 1 mark because the examiner need to say how you derived it every time. Yep. Okay, now have a look at this question. And we have a girl. This time we have a circular hump. Okay, the normal force, blah blah blah. Now we have a second rider has a mass greater than m. Okay, so let's name it m2. Okay, which of the following statement best describes the speed, velocity of the second rider so that the normal force on the rider at the top of the hump is also be 0. Okay, so if okay, so from it's a multiple choice question, but from the derived equation, okay, it's the minimum speed when it flies away. Okay, for the normal force to be 0 is r times the gravity, square root of r times gravity. So mass is not a factor. Okay, it doesn't matter how heavy it is. So your answer will be A. Okay, if this is an explanation question, okay, you can write down this equation. Okay, you can use this equation to explain. Okay, so just write down this equation. So since mass is not relevant, because mass is not relevant, so the velocity will be the same. Because the radius doesn't change, the gravity doesn't change. Okay,